Good afternoon, everybody. We've arrived. This is the last installment of the conception to completion scanning and LiDAR series that we've been doing over the last 6 to 8 months. We are going to have all of our dream team, what would I say, dream team LiDAR and scanning team. How about that? Talk today a little bit about bringing in all of this data together. Operating in a efficient manner relative to deliverables and different sensors. And we're going to wrap up all of the different sessions that we did briefly while we do this. And I guess I will just give a couple housekeeping items. Again, we will record this session. It'll be in our YouTube page under Frontier Precision. If you do have a question, please put it in the chat. We'll answer those at the end. And I think that is about it. With that, I'll turn it over to Bob Green.
Hi, everyone. It's Bob Green. I'm a geospatial analyst at Frontier Precision, and I'm going to be kind of your master of ceremonies here going through the next hour. Although we may run a little long, I'm hoping not to, but if we do, we hope you would continue to join us because we have a lot of information to cover. My background is up there on the screen, but basically at Frontier Precision, I do a lot of testing, consulting with customers, even projects with customers. And currently I've done a lot of writing of published articles for various magazines and kind of keeping the industry up to speed on what's happening in space and how that affects what we're doing here on the ground. Even though I'm not have a lot of experience on the UAS side as far as the two fingers are concerned and the control of the unit. I do have a lot of experience working with 3D spatial data. I started with terrestrial scanning back before Trimble even had a scanner. So it was back in the Cyrax days. And it was crude, but at the time we thought it was the best. And I think that's the way it kind of goes. Everybody says, wow, look at this, until we wait till next week and something else comes out. So I'd like to introduce the rest of the team. So if you go to the next slide. With me today is also Dylan Jones out of one of our Minnesota offices. Dylan is a AGE or Applied Spatial Geospatial Engineer with Frontier Precision. He's been with us for about 8 years. He focuses mainly up in Minnesota, but with the technology, especially on the terrestrial side, does a lot of traveling as well. And he's an expert in the MX9, MX50. MX50 is a fairly new product from Trimble, and he also does a lot of training and consulting. Next slide, please. Not with us today, but part of our team was Troy Hernandez. Troy is traveling today, so he'll not attend, but he did help collect a lot of the survey data that we're going to be looking at and partnering with me to do some of the processing and analysis. So I just wanted to make sure we included him as well. Next slide. Also with us, who will be focusing mostly on the drone side. Nathan is the one that collected this data on our beta site out in the field. He's also the one that drove it on the terrestrial side as well. He has a strong background in remote sensing, as you can see on the screen. He's also a FAA Part 107 pilot. He does a lot of traveling for us as well. As you can imagine, you know, there isn't that many MX9s out there in the market, so we do have to do quite a bit of traveling with that unit. Also sharing his knowledge with training both in person and online. And right there at the bottom left is a picture from our site that we took. So we actually did this job. The team that I'm showing you here, we all partnered on getting this job done with 3D sensor data. And then near the end, we're going to show you a deliverable that is going to look very standard, but a little bit enhanced, or quite a bit enhanced, from what you're used to seeing on a traditional deliverable. Next slide. Next, we have Matt Schwartz with our building point. Matt's on the build side, or the construction side. He's been with Build for 19 years, and he's actually filling in for Robert Beck. Robert was the one that was a part of our team on the past 4. So I'd like to give a shout out to him for all of his help that he's given us. But Matt's going to fill in, and really we're going to end with Matt as well, kind of showing some of the technology of today and what is happening and moving forward in the future, which will hopefully prime the pump for another webinar series, probably starting sometime in the spring. So welcome aboard, Matt, and he will be joining us here during our session. Next, I'll now hand it over to Dylan, who will start with a recap of our mobile LiDAR solutions and applications.
Thanks for the introduction, Bob, and hello, everyone. Just to recap what we talked about in our second episode of this series, which was regarding the mobile LiDAR side of things. I'm going to just speak a couple slides of what happened in that webinar. So with mobile LiDAR, as you can see here, typically a vehicle-mounted data capture system where you could obtain a 3D colorized point cloud like you see up in the top left corner, and as well as imagery, so pretty much like a Google Street View of your own. So utilizing multiple sensors on board these vehicle-mounted systems to capture and document along the way. In our project, or on our project, we utilized the Trimble MX9 that you see there on the left. You can see it actually mounted on Nathan's vehicle in the middle. And then we also have an MX50 that we would potentially use on certain applications and projects as well. Forgot the 0 there at the bottom, but that is an MX50 if you were wondering. As far as applications go, we talked about a variety in our previous sessions, but just to include a few here on the screen for you. If you're working heavily in the DOTs and highway survey work, this is definitely right up your alley. We see a ton of use in the utilities, energy, mining sectors as well. Then if you're with a county, a city, or any other type of municipality, and you're looking to collect data, especially asset information to build an inventory, a GIS, or to build a digital twin, kind of keep a record of your streets and the condition of the pavement. This is also a very great technology for that. And then lastly, rail corridors. You'll find that mobile mapping is primarily best used on corridor type projects, especially large scale projects. So I'm going to pass it back over to Bob, I believe, who will talk about the terrestrial scanning.
Yeah, thanks, Dylan. So on this particular project, we use the X7 scanner. We could have used the SX12 or a variety of different options, but we chose this because of the speed and versatility of the X7. A matter of fact, I'm up right now at the PLSO conference up in Salem, Oregon, where I talked about ground control and different ways to establish that ground control. We're going to hit some of that here at here in a bit on this presentation, but we had one of our guys, Jarrett Price, do a presentation on how to turn this scanner that does not need to be even level into a total station to a degree for certain applications. And it was really interesting watching that workflow. It was kind of new to me because none of us know everything. So people pick up and come up with a theory and test that theory, and that's kind of what he did yesterday here at the conference, and then I spoke this morning. So anyways, we can go to the next slide. Terrestrial scanning has been around for over 20 years. But the problem was back in those days with any kind of point cloud data is you could collect it in the field, but you download it to your computer and it would lock up. And that is not the case anymore. And so we have a wide variety of applications. On the industrial side, Matt will cover that for us. On the build side, of internal renderings for 3D scanning. Change detection is a huge one coming up in the marketplace. As a matter of fact, Frontier just partnered with a company called Synspective out of Japan. They own a series of SARs, or synthetic aperture radar satellites that are low Earth orbit, sun synchronous orbit, so that they pass the same point on Earth daily, and they can give us a couple millimeter accurate positioning from a satellite in space. So as we move forward, we're almost going to have LiDAR from space. Now, this stuff is not as dense naturally as what we're getting here, but the possibilities with this type of technology from space interfacing with what we're talking about today, especially like we just witnessed the landslides in California, all that kind of stuff, we could have monitored that all from space. And a big thing with this technology, whether it is on a X7 or an SX12, is excuse me, I had my phone shut off there, is the ability to do topographic and improvement surveys, and then have the bulk of that work be drafted by office staff. So that Jarrett showed yesterday as well. And if you go to the next slide, roadway intersections. So safety is a big one where you can do a scan of an intersection and avoid yourself having to get out there. So manholes and valves and all that can be located remotely. Substations is huge. I did a big substation survey up in Hereford, Colorado, all for infrastructure. So we used to say GIS was get it surveyed. Now it's get it scanned. We also have oil field applications as well, where you can take oil and gas infrastructure, give it a 3D rendering, depending on your distance constraints, would define what scanner you are going to be able to use. And a huge one, especially in my neck of the woods in New Mexico, is historic preservation of doing scans of historical entities and then making 3D renderings of them so they can be retrofit. It's big too in the electrical transmission. So, a lot of substations date back to the 50s and 60s. Those parts are not manufactured anymore. So if something goes wrong, you have a 3D rendering. And that whole kind of falls into that digital twins movement. That would be a totally different webinar, but heading in that direction of everything going 3D. A matter of fact, at Trimble Dimensions, Rob Painter was talking about the first bridge in Europe that got built totally 3D, no 2D drawing, the whole thing digital twin moving forward. Next slide. Now I can hand it over to Nathan, and Nathan is going to talk about the drone side of the fence.
Thank you very much, Bob. So I wanted to just quick recap the equipment that we used for this project as well. We used a yellow scan mapper. That's the sensor in the upper left of your screen right there. And we used a DJI M300 kind of in the middle of your screen to capture the data that Dylan would be talking about eventually. We do also have quite a few other products in our portfolio, so reach out if you have some questions. So these are just some of the applications for airborne scanning. We did do an entire webinar on this, so I don't want to spend too much time, but raw land development surveys are probably the largest one, especially catering to land surveyors as our bread and butter here at Frontier. So being able to capture swaths of data over large land areas, removing trees and brush and things like that, and getting down to bare earth to derive your contours and surface data. One of the other biggest things that we see a lot is power line surveys. So being able to capture long linear corridors from the air and getting things like how high those lines are, the installation of the different beams and stuff like that. And then one of the other things that I wanted to stop on here is efficiency and ease in survey and engineering. So typically speaking, it can take a long time to collect some of this data out in the field if you're doing it boots on the ground using either GPS or total stations. With some of these sensors, we can collect up to 100 acres per flight in just under probably 20-25 minutes. So we really get some efficiency in that. Go ahead, Dylan.
Okay, so I'm going to take over for the building construction side. I'm Matt Schwartz, as the name suggests, or as the name says on the screen. So for the building construction market, the workflows are a little bit different than in the survey world. I mean, ultimately, we're using very similar equipment. On the screen here, you can see we've got an RTF 773. That's essentially the same total station that Trimble makes under the S-Series brand. Bob already talked about the X7 scanner. It's the same scanner on the building segment for Trimble with their distribution. We've got similar products with just a different workflow. So RX7, instead of using perspective like you might see if you are on the geospatial side, we're going to use Trimble FieldLink, which is Trimble's layout software. Some different workflows are built into that are specifically tailored to the construction market. I'm going to talk about those here on the next couple slides. And then the last product that we're going to talk about before we switch sides is going to be the XR10. So the Trimble XR10 is essentially a private labeled and purpose-built HoloLens 2 device. So some of you that are in the architectural field, you might have already seen the HoloLens 2 from Microsoft. Trimble has had a very long partnership with Microsoft, and they, like I said, purposely built their own device that is mounted with a hard hat. So it's been certified for use in the field on active construction sites, so they don't have to worry about having proper PPE. That device is all ready to go. It's got a little bit bigger of a battery and then a flip-up display, so the operator can physically walk around a job site and take it out of the way if they need to, and then bring it back down. Specifically, this XR10 is going to be really for visualization of the model in the field. So that'll be the kind of the wrap-up slides that I'll talk about at the end of this. And the visualization part is where things are going in the future to be really powerful. Pictures worth 1,000 words. So Dylan, next slide, please. With scanning, some of the biggest workflows and the biggest benefits of the workflows are going to be as little hands-on of the scan data to get your deliverable as possible. And one of those is multiples of those are going to be either loading the 3D model of what you are trying to build into the data collector and then performing your scanning and then comparing the two. So in that first top image there, you can kind of see that we've got the green ductwork. So we've got a MEP, a mechanical ductwork system loaded into there. And then we've got our point cloud data. And it appears that we are going to have a clash with that duct and that installed plumbing pipe. So right away, we can identify an issue. With construction, things move very quickly. And so if you spend too much time getting a deliverable, you miss your window of being able to address issues when it saves you money. So the construction market really looks for in-field workflows that move at construction pace and speed to recognize issues as soon as possible to save as much money as possible. And then the lower picture there, instead of a full 3D model, which not everyone has access to, they're simply overlaying a PDF. So we've got multiple options for in-field workflows. With the PDF, it's just a normal plan, and we can overlay that, and then you can compare. Right now, we've got an elevation color code loaded into there, and so you can see on the ground near that column that there's a couple sleeves that are sticking up. If we have that PDF overlaid and it clearly is showing that we are not in the wall, a project engineer or project manager or foreman or whoever is on the construction site can simply scan with the tablet, look around, identify issues, again, an in-field workflow that moves very quickly, very agilely, and fixes problems. And now just a little quick tidbit, with the advent of robotics, we've now got the Boston Dynamics partnership with the Spot platform or Spot Dog that can go around and actually scan for you. So again, inside FieldLink, the Trimble layout software for the build market, we have the ability to essentially launch or set up a mission and then launch that mission daily or whatever interval you want to do. And Spot will simply travel around your construction site, stop at designated locations, capture the X7 scan data of all your point cloud information that you need. And then when you come in the morning, that's ready to go. So hands-off workflows that require less people to physically be on site. A lot of times this will run at night when everybody else goes home. You just make sure everybody cleans up the job site, and then boom, it launches a mission, come back in, and you're ready to go and identify issues and have your meetings with the appropriate data rather than 4 or 5 people running around with scanners at night. So really allows for a quicker workflow and quicker reaction time. So next slide, Dylan. So again, getting back to quickness, another workflow that we have inside FieldLink is the ability to load in that 3D model that I talked about on the previous slide, but now we can actually do an in-field comparison of the model versus the as-built point cloud. So if we do a resection with the X7, which is popular, Bob kind of touched on it with the kind of a survey workflow, it has a laser pointer inside of it, and if you do that resection, all of your points will be captured in the same coordinate system as your model information, or as your model information is, and then therefore you can do this inspection tool, again, running on the tablet, and it will color code issues so that you can very easily see where you are going to have problems or where we have deviations from the design. So if you see a lot of red on your screen, in this case, the little color bar says that we're 3 inches off, so that would clearly be a big issue. In this case, we can see a lot of green, so we are good to go. So again, a really quick workflow scan, doesn't take a lot of time to scan, and run the inspection on the tablet, and you can have your answers in minutes rather than the old workflows of scanning, come back to the office, process the data, load the data into another software package, and then it was potentially days of time, or at the very least hours and hours. Now we can do this in minutes. Go ahead and do the next slide, Dylan. And then the last one that we're going to talk about is going to be a floor flatness analysis. So a big thing with the concrete market, every major floor in buildings is going to have a FF and FL number, floor flatness and floor levelness. Inside of FieldLink, we now have the ability to generate a 2 standard report according to the specifications laid out, and we will get numbers that you can use instead of doing the traditional dipstick method. Or in talking to Bob yesterday, he went through the old way of doing it. This was before my time, and it was very complicated. I mean, he was talking about micrometers on auto levels and INVAR rods and a whole process. This can be generated in minutes. A little picture up at the top there, they've got the scanner set up. You can, using the scanner, generate this information, or at least point cloud data, in many different intervals. So you can do, if you want to check subgrade, you could scan out, set up, scan, capture the information of exactly how flat the subgrade is and verify that that's it to elevation, or at least close. And then you can go through and you can scan post-pour directly after, before troweling, to verify where you have high and low spots. Those can be addressed, those can be finished out, and then afterwards, after everything's done, trowel's all been taken off, and you think you have your flat floor. Now you can come in and actually prove it and get the generated report in a PDF format that shows, yes, you did your job according to the specifications required by the engineers or the owner of the project. So very quick workflows again. There are several more, but those are the 3 that we really wanted to highlight on this, in using models and just generating stuff in the field very, very quickly. And with that, I'll turn it back over.
Okay, so now we're going to get into the survey portion, and right here is just kind of a Google Earth screen snap of our area of interest that we're going to survey for this kind of beta test of merging all of these multiple sensor data. And you can see the layout there, and I think we'll get into more detail of that here in the next slide or so. So could you go to the next slide? And here we got a video of the zoom into our site. And we also are looking at the area that we did with the MX unit, kind of a little bit bigger than our area of interest, but that's the beauty of it. It doesn't take that much more time. And additionally, if we needed to do any type of drainage calculations or hydrology or anything like that, we do have the additional information from all that additional resource that when it was drove with the MX unit. And we also are now going to combine the MX data with the aerial drone data, the terrestrial data, and into our survey that I'm going to go through here in the next few slides. And there is our culvert of interest. So for example, let's say, for instance, you can kind of see it a little bit. It's not in the best shape. So perhaps we want to replace that culvert with a bridge. And that's the purpose of our survey. So like any good surveyor, we have to put down ground control. It is possible with our PPK, some of our PPK technology, to put minimal ground control down, but it's nice to have checks, warm fuzzies. And so you can see here that we have a panel that we put on the ground, PK nail set. What we did in our survey was we had 3 main control points, and then we, from those main control points, shot in the actual panel points, or GCPs as they're called now. And these can be a multitude of different types. Traditionally, some form of a chevron or a panel, or a traditional, back in the old days, we used to have panel material that we'd lay on the ground. I actually have a mine that uses 50-gallon drum lids that are welded to a steel pipe and painted. So they work great, and they're there time after time and redundant because they don't have to redo them each time they fly. Go to the next slide. This is my survey. I probably should have also zoomed into my area of interest, but there's 3 main points there, 1 north, 1 mid, and 1 south. And just for kind of experimental purposes, I did static in the north and south point, and then RTK'd in the middle point. So I did kind of my own opus. You can see my geometry isn't 100% perfect. It's a little tiny bit extrapolated, but you would think Metro Denver has a lot of core stations. They really don't. And so anyways, I did this because I like doing my own work and then using the government in order to check mine. So Opus is a great utility for day-to-day stuff. But when I come to projects like this that are going to be almost perpetual, that I'll be going back and forth to, I like running a static network adjusted survey. Off to the right, you can see the air ellipse components of my adjusted network, and we're looking at in the thousands. I mean, we do have 0.3 that has a couple hundredths, and part of that reason is 0.3 was the midpoint and was the one that we RTK'd in. So we didn't static it in, we RTK'd it in. And you can see the other 2 air ellipses have the same azimuth relationship, and the RTK one doesn't. But nonetheless, we did our own thing, did it old school to try to tie old school into new school. Next slide. Here's a copy of my network adjustment report. Again, I have my error ellipse components at the bottom, all of my adjusted both grid values. We did this initially, at least on state plane, the adjusted geodetic latitudes and longitudes, and the adjusted Earth-centered Earth fixed 3D, which I'm hoping that sometime in the future becomes a global coordinate system instead of using antiquation. And then we have our observation data and my little histogram of standardized residuals, or the residual divided by the standard error, with normal distribution is that black line. You can see it's kind of a funky looking histogram, mainly because I did RTK that one point in. There's a little spike in the middle. A spike in the middle of a histogram usually indicates precision over accuracy. And down at the bottom right, you can see kind of the layout of some of our check shots and things of that nature and panel points that we put down on the ground. Next slide. Here is, and I just want to bring this up, it's just a hair off topic, but when we set up, any of you Trimble users out there, when you set up your survey styles and Trimble Access, you have a tendency to always, just like myself, why do I pick things? Because they worked yesterday, of using QC1 and QC2 in your survey style settings for your topo points and observed control points. QC2 is your variance covariance matrix, and really you don't use it unless you do a network adjustment. Other than that, that data kind of goes by the wayside. It's there, it takes up space. And I'm having a tendency now to log QC3, and I show QC3 there at the kind of on the right-hand slide. QC3 is our error ellipse components, and also unit variance is Gaussian, random versus normal distribution, doesn't really matter. But I'm trying to work with Trimble to get easier access to this QC3 data, because I think it makes more sense to log it out in the field. But we'll do a webinar on that topic in itself in the future. Next slide. Now I'll hand it back over, and we'll continue with the combination of all this data into one seamless project.
Thank you for that, Bob. So I wanted to do a quick recap of how we collected this data before we jump into how we extract data out of it. So Dylan will be going over that portion, but I want to just touch on how we collected it once again. So we used the Trimble MX9 mobile scanner to collect the roadway. The Trimble MX9 you can see on my vehicle there on the left, mounted on the roof rack. So there is some dynamic driving associated with this unit. Basically, we need to do some velocity forward and stops, take some left turns, take some right turns to calibrate the IMU sensor that's inside of it before we collect our data. So we did that for approximately 10 to 15 minutes. And then we did 2 passes, one going northbound and one going southbound, to make sure that there wasn't any shadows or incompleteness in the data. Go ahead, Dylan. And like I mentioned before, we use the yellow scan mapper. You can see on the left, it's flying there right above the vehicle. We do a calibration and IMU calibration with this unit as well. Since we can go backwards much easier in the sky than we can on the ground, we do a forward back forward J hook in order to calibrate that IMU before we collect the data. And then this specific flight that you can kind of see on the screen here took approximately, I think it was about 18 minutes to capture this point cloud that we see on screen. Go ahead, Dylan. And then finally for that culvert, right, because we captured the data on the road, we captured the data kind of in the ditches and in some of the other areas that Dylan will highlight, we still had this culvert that neither of these sensors would capture. So we broke out our Trimble X7, which is a static tripod-based scanner. Bob mentioned before, it does not need to be level. It can level itself to a certain degree. So we use this to kind of traverse through these culverts and capture that data underground. Go ahead, Dylan. So the biggest question then is, how do we combine all this data into one point cloud, one cohesive point cloud, and then make sure it's good? So we brought all of this into Trimble Business Center. On the left-hand side, you can see the Trimble MX9 mobile data of the roadway. And then on the right-hand side here, you can see the yellow scan mapper point cloud that we collected from the air. Go ahead, Dylan. And then this is the Trimble X7 static scanner data on the bottom that we collected on the ground. So like I said, we brought all of this into Trimble Business Center, and we combined those using the georeference scans tool, as well as the refine and register scans tool. So this is a really quick picture here showing that registration process. So the green is the static tripod-based scanning point cloud, and then the brown is from the yellow scan mapper. So basically we used common features and commonalities between the point clouds to register those together. So basically we have one cohesive point cloud from the mobile scanner, the airborne scanner, and the tripod scanner. And that's what we used for the basis of all of our data. So lastly, before we extract data manually or semi-automatically, one of the things that we did is point cloud classification. So TBC has an awesome tool that can classify a number of things. Mainly ground is what we're after, but it can classify things like buildings and high vegetation as well. So right now we're looking at a color-coded point cloud where brown is ground, green is high vegetation, and blue is buildings.
And then I'll take back over here when it comes to the 3D line work deliverable. So as I presented in the second episode of our series, I demonstrated how a lot of that roadway line work was extracted, utilizing a variety of different tools, from some of them being a little bit more manual, some of them being a little bit more automated. But if you're looking to see how I extracted all this roadway data that you can see here up and down the roadway, lane lines, curb, gutter, sidewalk, and then getting into some of the stuff that was collected more so with the aerial LiDAR, being this bike path and this creek. Just the various ways that you could do that are involved in our previous session. So I wanted to point those out here. Those are up on our YouTube page under the Conception to Completion series playlist. So just pointing out some of those in which we demonstrated the line work, and additional to the line work, some point cloud sampling and 3D surface modeling as well. So I urge you to go watch those episodes to see how we did that. And then what I'm excited to present on that's relatively new today in today's session is how we take that 3D line work, the point cloud data, the surfaces, and combine all that into a little bit more traditional deliverable that a lot of surveyors are used to. So what that looks like here to begin is to first establish a CAD template. Okay, so a lot of users, a lot of companies and organizations utilize CAD templates to start off their drawings. And so we did the same exact thing here. And you could start from scratch and develop your own layers and colors and styles within Trimble Business Center, which is where we did all this work. Or you could import a DXF, a DWG, a DWT, or a DGN from an alternate CAD software. Bring all that information in that might already be established in those software packages. Just do a simple import there, and you would have all your established layers, colors, and styles, among other things. So from that position, we then would save that as a TBC template for any future use down the road. So establishing the CAD template was really my first step in the process, and you can see things ported over perfectly from an existing DWG drawing from Civil 3D. So this background picture showing the layer manager in Civil 3D with the various colors and line types, and really that was just a drag and drop of that DWG into Trimble Business Center, and I end up with all those same layers here in the TBC layer manager. So that made it very easy for me to draw all that line work onto proper layers. And I have a few tips and tricks here that I want to share with everyone, those being with the View Filter Manager. So when you are working with LiDAR data from not only one type of sensor, but 3 different sensors, it can get a little bit, it can be a little challenging to show and hide the things that you want to work on while you're drawing that line work, while you're producing your deliverable. And so one of the things that I wanted to point out here with this view filter manager, which we use all the time, in my training experience, I don't actually see a ton of people utilizing a variety of view filters. So I pointed out here up at the top a variety of view filters that I created in my project. One of them being this CAD simplified view filter, which just simplifies things to just my CAD line work. I have one for my culvert cross section, and then I also have one for just the point cloud only. So it really helps save you time. Whereas normally, if you're not using a variety of view filters, you kind of have to go into these layer groups here that you see in gray, expand those and turn off specific layers, turn on and off checkboxes. It can take a lot of time to do that, to find exactly what you're looking for. Whereas if you use the view filter managers, that definitely speeds things up, allowing you to stay organized and just really visualize things in a much more snappy way. And so this is a video kind of demonstrating me switching between my different view filters. There's my cross-section data with some point cloud as well. Here I switched over to the point cloud only view filter and then my CAD simplified filter. So I didn't have to check any boxes or really do anything other than hit a drop-down arrow and select the view filter that I wanted to be viewing. And along the top of that view filter manager pane, you'll see a row of additional tools there that really come in handy when you're QA, QCing your CAD drawing. So one of those being just demonstrating here at the bottom video, the isolate tool. The isolate layer tool allows you to just simply click on a layer and it zooms and perfectly centers everything on that layer and hides the rest. So isolates layers very quickly, allows you to really understand what's on that layer. If there's anything that doesn't belong on the layer, you can quickly relayer it onto another one. That really helps speed things up when it comes to just doing the QA, QC portion of things and finalizing your CAD objects. Okay, and then we mentioned creating surfaces in that second and third session of our series, but here I'm utilizing this, I utilized the merge surfaces tool to get all of my various surfaces combined into one. So you saw I had a surface dedicated for just the creek, a surface dedicated just for the aerial LiDAR ground data, a surface for my road, and then I began merging these all together until I had one final merged surface. And so you can see there that merged combined surface all in one. And then from that, I created my surface contours. All right, so there's your contour tool to produce your contours at, you know, with a variety of different settings available to you, different distances for labels and contour intervals, and you can kind of see how that ended up here. Going forward, this is where we now start getting into creating a plan set. So in Trimble Business Center, you have what's called drafting templates that are provided to you. You don't have to use a drafting template. You can create a plan set from scratch, but I find it to be very useful to utilize these drafting templates that Trimble provides. And so over here, this is in our drafting ribbon, you'll find this drafting templates button, which opens up this folder on your computer of all of the variety of drafting templates available to you. So if you wanted a 24 by 36 plan set, you could just simply drag and drop this VCL file right into your TBC project, and it establishes a plan set with a variety of sheets to go along with it. So if you're doing a simple plan, or maybe a plan and profile, maybe you're doing some corridor cross sections, they've already provided you the sheets to establish just the groundwork of it all. And so you'll see on this slide what that looks like at the very beginning. So what I've done here is I've created a view showing the title sheet. And so this is the master title sheet, I can, you can see that it's pretty much blank, waiting for me to populate, you know, the description, the title, project location. I can now start adding in text and other figures into my sheet view, and I'm constructing that deliverable that we're used to seeing. Next, customizing those master sheets with title blocks, legends, north arrows, etc. You have a variety of tools on the drafting ribbon to go along with that. So creating a north arrow, creating a scale bar, inserting a logo here that you can see, creating text objects. So I created all the different lines here for my legend. Going forward, what you would do next is create what are called Dynaviews. So this is where it allows you to use your model view, essentially your actual line work here on the left, and creating something similar to a viewport that you would see in AutoCAD. I'm just kind of speeding this up here. I'm creating a frame and dropping that frame into my sheet. Okay, and now it's dynamically linked to my model. So if I make any changes to my model on the left, it'll update that on my sheet. And I can kind of reposition that, rescale it, move things around on my sheet to make things fit the way I want them to look. But the idea here is to utilize what are called Dynaviews to port your 3D line work onto your 2D plan sheet. And this is the final product that I came up with. So after maybe a few days of work, extraction, creating surfaces, pulling in some boundary information from the city, I was able to construct this topographic design survey on a 2D piece of paper. And then I could print this out, right? So print this out on a plotter or a 3D PDF, even if I wish to do something like that. I also created a sheet, a cross-section sheet showing the culvert. So this is a cross-section of the culvert. I utilized Dynaview to create this as well. And I also implemented I included some vertical clearance measurements. So you can see here my vertical clearances from the ground or from the creek up to the bottom of the concrete structure. I have my road centerline elevation over top of that concrete structure, and my ground surface, and a variety of other title block and labels and things to go along with that. So that was my deliverable. My end goal was to create something like that, all from simply all from LiDAR information. Now I'm going to hand it off back to Bob, and he's going to talk about how he utilized that culvert scan in Trimble Realworks.
Yes, and for an additional deliverable, we can build 3D models, and Trimble does have a platform called Trimble Realworks, which is kind of a point cloud management software. And I took the point cloud from Trimble Business Center and I brought it into Trimble Realworks to see what I could do with it and what enhancements I could make it to deliverables. So if you go to the next slide, you will see I created this 3D model of the culvert from that point cloud. So I used in Trimble Realworks a modeling tool. It was called Cloud-Based Modeler. And I modeled that existing unit. And then I kind of roughed out a floor of it, even though the floor is dirt. You can kind of see the creek there running through just to kind of close it off. But this could be given to an engineer as well to do measurements on. You can see I did one measurement, but there's a measurement tool bar right above there that you can do a ton of different clearance measurements, angular measurements, all that done right in Trimble Realworks. This could also be handed off and then handed to somebody that could possibly design a bridge, let's say. And that's kind of where Matt's going to take over. We didn't design anything on this particular project, or we may do another one where we do, but he'll kind of mimic what you could see through some of the construction applications that we could use moving forward once this topographic design survey was given to a engineer. Next slide.
Yeah, so as Bob alluded to early in the presentation, there might be another presentation that we're going to put on this spring that is going to deal more with the mixed reality segment of the Trimble solutions that are available out there now. As I kind of said earlier as well, mixed reality and a picture's worth 1,000 words. It's really a emerging market with being able to visualize what you need to build, or what is the design intent, or in some cases what is proposed out there, or what is existing of what you are supposed to be adding to on a potential survey. So Dylan went through the whole process of developing a PDF. We had one on the previous slide, and this is what you can use inside of Trimble Access using the product called Sight Vision that allows you to overlay that PDF in the real world. So you can kind of see in the middle there, there's that light spot of not white that you can see that's actually the roadway line coming through. And so you've got the extents of the roadway, and then you can see the hill going up there where on the other side is going to be. So a PDF overlay is a very simple thing to get. Virtually every plan that you're going to work on is going to have PDF available for you, or maybe you're going to be generating them, but they're involved in some way, shape, or form on most projects. And the PDF loaded in the SiteWorks, and even if you just want to use it, nothing more for Sight Vision, excuse me, nothing more than just comparing what am I supposed to be looking at? Is this what's here? We weren't able, just from a time standpoint, to show some of the other PDF things, but in this example that the customer was using, he actually found a gas line that wasn't in the PDF as being marked out, but yet it was located in the field. And so, I mean, even just that example alone is a potentially huge safety hazard, but something that he identified just by looking through what the proposed, what's out here versus what we're supposed to have. So visualization is a huge thing going forward, or it can be, and it's all about taking this new data that we're generating and that we have access to and finding new ways to use it. And then in this last slide, if Dylan, you can advance one for me. In this case, as Bob talked about, we didn't do a culvert, but the customer had a building. And so this is a proposed building that's going to go on this existing pad. And using Sight Vision, he's adjusting the transparency up and down, and you can see cut fill elevations, even if you're just looking at it that, or hey, where is this ramp going to be? Where are we going to have to move a bunch of material? Where am I going to have to be marking out things? We have both the transparency to control it, but we also have cross-sectional, so we can cut down through that model if we want to see inside of it. So that's what we're doing right there with this cross-section, so you can see inside of the building, and then all the way down. So you can see that we had quite a bit of cut for this building pad, and now we're pretty much at the elevation that we need to be. So being able to visualize these 3D models that we're talking about that are a potential deliverable of our LiDAR data. This could be ownership that wants to do it. Maybe we're working with the architect and they want to show ownership, have them walk around, and this is what your building's going to look like, or this is why it was extra to do extra soil correction. So there's all sorts of different uses for this new data that you're generating in the future. And like I said earlier too, look for a future webinar from us on some new workflows using this type of information and products.
Yeah, I wanted to add one thing. You mentioned it very briefly, but this is showing in the Sight Vision application on, let's say, like an iOS or Android device connected to a high accuracy receiver. If you're someone who utilizes Trimble Access on something like a TSC7 or a TSC5, and you also have an R12i GNSS receiver, this same technology is built into Trimble Access right now. That would allow you to load in surfaces and BIM models and 3D line work and actually be able to overlay that right there on your controller video screen. So just wanted to mention that, as we are talking about sight vision right now, but that's also in Trimble Access as well.
Yeah, thanks for clarifying that.
I think I can touch on this here really quick. Since I'm one of our survey trainers, I do provide training on Trimble Business Center. So if you're someone who's looking to get either on-demand training or in-person training, I'd be one of the guys that you could talk to set something up. And we do have this training.frontierprecision.com webpage. This is where all of our on-demand trainings are hosted from. So a lot of TVC, a lot of Trimble Access. There's a few free sessions in here. So Introduction to GNSS, Trimble RTX. There's a few other ones involving scanning as well. So check this out. Click on all courses. You'll get a full rundown on all of our on-demand courses. We also have a link to our YouTube page where there's a lot of free content there as well. And then be aware that we do have live trainings, in-person trainings at our offices that we hold from time to time. So check out our training and events calendar. If you go to frontierprecision.com, click on training and events up here along the top, and check out the calendar for any trainings or events that we are putting on here in the near future. And of course, all of our office locations. So whether you're at your local office nearest to you, or if you're around the country, note that we do have country spanning a good portion of the upper Midwest, Pacific Northwest, the Pacific, as well as some remote offices in Utah, Florida, and Texas as well. So reach out to us if you have any questions, or if you'd like to just stop in at any of our offices, we'd be happy to see you. So with that being said, do we have any questions that rolled through?
Hey, Dylan, this is Nathan. We had a couple of small questions here. One of them was, can we X7 upside down?
An inverted X7 scan?
Yes, sir.
How I'm interpreting that? Yeah. Yep, absolutely. The X7 can be run inverted. So if you're someone who's looking to do subsurface scanning, scanning manholes, or any utility vaults or things like that, that can absolutely be performed with the X7 scanner.
Yep. And I did want to touch on one part, follow up with that part of the question too. He said, how far would this out of level still work? So kind of two separate questions. And the answer is plus or minus 5 degrees. So you've got 10 degrees total of range for the unit to level. And the X7 is a little bit unique in that you have that automatic leveling, or the automatic adjustment to the scan data within that 10 degrees, but it is also a survey grade compensator. And so there is a very well-known Swiss competitor of ours, or of Trimble's, that makes a unit as well that is kind of feature-wise looks comparable, but if you actually drill down into the information of the unit, the RTC leveling is not nearly as accurate as the X7. So if you do put it in that 5 degrees of window, plus or minus, then you will get a true accurate Z for your scan data, which is not necessarily the case with the RTC unit.
Looks like there's a question regarding drones and what drones work well with carrying LiDAR sensors. Nathan, do you think you could answer something like that?
Sure thing. Thanks for that, Dustin, and I'll follow up with you separately as well. So basically, we have a couple of recommendations. For the small to medium-sized scanners, so think of the DJI L1, yellow scan mappers, yellow scan surveyors, things like that, smaller in nature, low weight. The platform that we recommend is a DJI M300, tried and true. They make lots of them and we've sold lots of them. For any of the larger scale, either in form factor or weight, we used to recommend the DJI M600, which is now end of life. So we can't get those, unfortunately, but the next one up is a FreeFly Ultra X, it's called.
Awesome. And then one question that just came in mentioning the X7 is faster and more versatile than the SX12. What are some key differences between the two? So I'm going to have a quick answer there. For additional information, even a demo, be sure to reach out to your local sales rep and schedule something up where you can discuss the differences between these two scanners. But essentially, the SX12 is a scanning total station. It can be used as a 1-second total station to run traditional survey traverses and topo and stakeout. It has very high power, very high resolution cameras, and it does scan slower. It's I think about 26,000 points per second, if you want to put a number on it. And the X7 is like a true scanner, right? So it does have a laser sensor to do discrete point measurements, so you can actually shoot single features with it. But it's more of a dedicated scanner that's going to do full 360 scans and definitely scan at a much higher rate of speed. So we're talking as little as like a one minute scan, potentially for a full 360, upwards to I think the highest settings like 14, 15 minutes. So you can get much denser data in a shorter amount of time is really what I wanted to mention there when it comes to the X7. But the range, you'll find more range out of the SX12. It's just a difference in the scanning technology. And then I think the last one here, before we close it down, did you have anything to mention on rotary drones, Nathan, or is that something that should be handled offline?
Yeah, I can handle that with Dustin offline, but basically what I recapped was rotary drones, multi-rotors in general.
Oh, gotcha. Okay. I think that's it. Then, Bob, do you want to just close us out then?
You betcha. So I'd like to thank everybody for attending. I think you can see that, the end result of a quality survey interfaced with quality products and quality data. We combine this into not only a traditional deliverable, but 3D deliverables as well. That doesn't mean that you have to have all of these tools. MX units are fairly pricey, and you'd have to do your own research on that. But really, with a LiDAR-based sensor, or even some cases photogrammetric sensor, coupled with a terrestrial-based scanner like an X7 or a SX12, you can produce these products as well. You can always feel free to give us a call. If you want my contact information, it's available in multiple places on our website. So feel free to keep in touch, and we look forward to seeing you at our next presentation. Thank you.